again so that you can see what I'm expecting one more time for your problem solving for chapter 9. Mariana deposited $3,250 in a savings account that pays 9% interest. I see compounded. That's telling me I'm going to need to use one of my compounding formulas. And then I see monthly, so that's telling me it's the general compounding formula. Assuming no withdrawals are made, how much will she have after 4 years? So that I'm going to write really quick. T has to be 4. This tells me general compounding, because it's followed by monthly, and then the monthly tells me n equals 12, and that's from the table we just wrote, and you can still even see it right here. 12 means monthly. And Mariana deposited a chunk of money, and then we want to know how much will she have. So that's how much will you have. That's the same keywords there to tell me I definitely need this formula. This is the starting amount or the present value or the P, depending on which formula version you're looking at. So the present value for the one that I wrote up above. So remember, first thing, I'm looking for that formula without anything plugged into it, every single problem. And so this one will be future value equals present value times the quantity 1 plus R over N raised to the NT power. And so my future value I'm still looking for. That's the thing I don't know, which is good because I don't have a value to plug in there. And then I'll have $3,250 times the quantity 1 plus my R. I'm looking back at my problem. Ooh, I never wrote that. I have 9%, so my R is going to be either use it as a percent, or you can look at 9 divided by 100, or just move your decimal 2 places left, but you should end up with R equals 0.09 when you plug things into the problem. So 0.09 over N goes there, and my N is 12. So I'll put that in, and then 12 is my N times T, which is 4. First thing I have to do, remember, is multiply that exponent out. 12 times 4. You can do that in your head, or you can do it on your calculator. Some of them are a little more complicated. This one comes to 48, so I'll just cross it off so I know I've done that part. Then working inside the parentheses, I want to do the 0.09 divided by 12. And I get 0.0075. So this one's got not that many decimals, so I can sort of write it out as I go. And if I add 1 to it, it'll be 1.0075, right? So I can write an intermediate step, make sure I add the 1 on my calculator, 1.0075, and then my to the button on this calculator is right there, to the 48th power, and enter. And now I have a lot of decimals. I do not want to lose them. So I have 3,250, 1.431, ... That means I know there are more decimals sitting on my calculator, and I'm going to keep using them. I'm not rounding. I don't want to round until the very last step. Take that 1.431, etc., and multiply it by my principal, which was 3250. Enter, and this is step 3. My future value in dollars and cents is going to be 4652.06, but I'm looking here and I see a 7 following the 6. That means I have to bump up the 6 to a 7. Bump it up 1, so plus 1 will give you 0.07 cents. Remember the rule for rounding. If the digit following the cents position is 5 or greater, then you bump up the cents 1 cent. If this number following is 4 or smaller, then you would leave it as 0.06 cents.